We all know something of the chemical properties of alcohol. It's odorless, tasteless. You can absorb alcohol in 3 ways. Most of us do the oral ingestion route. But you can absorb it through the skin, but it requires that the skin be broken in some way. And you can actually excrete alcohol in sweat as well. Mucosal absorption does happen. I just saw last summer, it was in the Journal of Forensic Sciences, an accidental overdose where the gentleman had created a wine enema type mechanism, and he killed himself overdosing on alcohol. It actually absorbs pretty well in any mucosal membrane. It's just not typical. So what happens in the stomach, our most common route, usually only about 25% of a dose is absorbed. And that is, well, it's just not a great surface for absorption. But ethanol also can be a stomach irritant. So the more you drink, the more acid-type secretions get going, and it becomes an even better barrier for the absorption of ethanol. So generally, the more you drink, the stomach kind of puts up more of a wall for absorption there. Okay? And they've actually determined that a 30% solution of any alcoholic drink will give you the maximal stomach absorption if you're into that sort of thing. So that's, I don't know, that's a pretty stiff mixed drink, I would say. So if anything that holds the alcoholic beverage in the stomach will delay absorption. Let's just go to the next slide before we talk about these kinetics. So most of the absorption is going to take place in the small intestine. The small intestine has a huge surface area. 3,200 square feet is actually a fairly large house from my perspectives, and that's about the area of your small intestine if you were to lay it all out. So that's where most of the absorption happens. And as we know, the colon can also absorb ethanol, but usually all the absorption is done by the time a dose gets to the large intestine. That's going to lead to, when we get this absorption going on in the small intestine, usually we expect that peak blood alcohol is going to be reached within 30 to 90 minutes of ingestion. Maybe in some circumstances this is up to 2 hours. But it's all pretty much dependent upon food intake. Okay? The more you eat with what you drink, the longer it's going to take to become absorbed, and the lower the peak blood alcohol is going to be. So you can absorb through the lungs, and they've demonstrated it in some studies, but those people had to wear goggles in rooms where they pumped in vaporized alcohol. I did read about a year ago that there were bars in London and all over Europe where you basically put a little mask over your face and you inhale vaporized ethanol instead of drinking. Alcohol is going to be distributed in the body in direct proportion to the amount of water. Alcohol binds very tightly with water. It stays with water. So the more water is in a fluid, the more alcohol is going to be in there. These are published ratios. Blood to serum. Serum is going to have a higher blood alcohol, or a higher alcohol concentration than the blood it came from. This is important to you because often you'll have a hospital blood result given to you. You need to know whether that is a whole blood result or if it's a serum result. With a clinical alcohol test, more than likely, 9 times out of 10, it's probably going to be serum. So you may be getting an artificially high number from that. I'm happy to look at the laboratory report or you can just do the conversion yourself. It's simple math. There's a partition ratio with brain, breath. We all know the 2100 to 1, blood clot, saliva. By the way, none of these are recommended specimens as far as I'm concerned other than blood or blood product. So this is how alcohol is metabolized in the body. There's an enzyme in your liver that will break the ethanol into acetaldehyde. So you got your 2 carbons here. You still got your 2 carbons, but you lost that hydrogen. That's why it's dehydrogenase. Okay? So it goes from the alcohol to the aldehyde. And then there's another enzyme in your body that will break the aldehyde into an acetic acid. This is probably what gives you the worst part of the hangover, is the buildup of these 2 intermediate metabolites, acetaldehyde in particular. It came to my attention over last summer that there's a significant portion of the Asian population which is deficient for this gene right here. If they drink any alcohol whatsoever, their face just becomes flush red. They can't drink at all, or they will get extremely ill because they don't break down this acetaldehyde and it builds up. They tend to just not drink, but when they try to. There used to be a product on the market called Antabuse that they gave to alcoholics to make them stop drinking. What it did was it blocked this enzyme, so it kind of induced this deficiency. You do also excrete urine, feces, breath, and sweat. Someone who drinks, I don't know, a lot. I don't know what a lot is, but the more you drink, the more you can induce these enzyme systems. It's kind of like a physiological tolerance. It's not behavioral. It has nothing to do with impairment. We're just talking about you can enhance the ability to a minor degree of how quickly you can metabolize alcohol. Smoking does the same thing. So does taking many drugs, because you're keeping these enzymes busy. The feedback systems in the body say, okay, we need to keep making these enzymes, so you can induce this to a small degree. Okay? We'll talk about zero order and first order in a minute, but basically, if you have a blood alcohol concentration of 0.02, which is not that significant, your body is metabolizing alcohol very, very quickly because you haven't overwhelmed the enzymes yet. Once you get above 0.02, it becomes a linear process.